So we've looked at systems of equations where we got answers for x, y, and z. The last example, we didn't have any solutions. There was nothing that worked. There was no solution that would make those equations true statements. And now we are having this last example, which we will also have a different situation. Some of you might guess what it's going to be, but let's take a look at it. So once again, I did label to help us keep track. So looking at the equations here, I'm noticing for A and B, I have a 2y and a negative 4y. So I'm thinking that we could eliminate the y's pretty easily here. We could also eliminate the z's. I'm going to go for the y's. So in order to do that, this 2y has to become 4y. So we have to multiply by 2. So we're going to take equation A, and which is x plus 2y plus z equals 8. And I'm going to multiply by 2 to get 2x plus, wow, bad handwriting today, 4y plus 2z equals 8. So multiplying all the terms here by 2. Then for equation B, there is nothing that we have to do for B. So this would be B here, but I can just rewrite it. 3x minus 4y plus z equals 4. So now when we add these equations, these cancel, the y's cancel. 2 plus 3, 5x, plus 3z equals 12. So we've eliminated the y's. Now I'm going to use A and C. And so I'm going to take equation A again, x plus 2y plus z equals 4. And now C, 6x minus 8y plus 2z equals 8. So working with these two, we've eliminated y. We need to eliminate y again. I'm going to multiply this top equation by 4 because to eliminate negative 8, I need a positive 8. I have a positive 2. To turn the 2 into 8, I need to multiply by 4. So multiplying this entire equation by 4, 4x plus 8y plus 4z equals 16. And then this one, nothing has to be done to it, so we just carry it over. 6x minus 8y plus 2z equals 8. Again, the y's cancel. We intentionally set it so it would cancel. 4x and 6x is 10x. 4z and 2z is 6z. 16 and 8 is 24. So these are now the two equations we have with x's and z's. So we have to now continue with our elimination. So down here we have 5x plus 3z equals 12 and 10x plus 6z equals 24. Some of you might be noticing something here. I'll wait to talk about it. Which we want to eliminate. Let's say x's. Some of you might see this equation here is just this top one doubled, so maybe everything will cancel, but let's take a look. So to eliminate x, I'm going to multiply by negative 2 because I want to change positive 5 into a negative 10 so the x's cancel. So here I have negative 10x minus 6z is equal to negative 24. Don't have to do anything to this equation. Whoops, over here, negative 2 times 12, this is negative 24. As I said, you need to be careful, and I'm rushing a little bit to get this video done and made a mistake. That could be very problematic. Fortunately, I caught it. So now we have the two equations. Let's add. Negative 10x and positive 10x, x's cancel, they're gone. Negative 6z and positive 6z, z's are gone. So we have 0 on this side of the equation, similar to what happened up here. However, now on this side of the equation, look what happens. Negative 24, positive 24, those also cancel. So different from this situation where all the variables were gone, but we still had a constant, a number on the other side. In this example, both sides cancel to 0. This is a true statement. 0 does equal 0. So in this case, there are infinitely many solutions. What this says is that you can pick a value for x, y, and z, and they will work in this solution. If we look here, we will see that with these equations here, this equation multiplied by 2 gives us this equation here. Another way to think about it is if we divide this second equation by 2, we'll end up with the same equation. So even though it looks like different equations, it's the same equation. So it's not just one x, one y, and one z. There are infinitely many solutions we can come up with.